Shock. Shock means, it's a rectangular pulse of time duration t1. Shock is also a rectangular pulse with time duration t1. But if the time duration t1 is less than the natural frequency of the system, then you call it shock. If the time duration t1 is more than the natural frequency of the system, it is not shock. So why shock is modeled mathematically by vibration scientists as a rectangular pulse of and usually of time duration less than t1. So usually the non-dimensional ratio t1 divided by tau is used, where tau is the period of natural oscillations of the system. So a non-dimensional ratio t1 by tau. So if t1 by tau is less than 1, then it is called shock. If t1 by tau is greater than 1, then it is not called shock. It is a general general excitation function. So this must be kept in mind. Why shock model is important? So when we talk of shock, we are only talking about the width of the rectangular pulse, single rectangular pulse. Now, depending upon the width of the pulse, the response of the system will be different. And what do you mean by response? Response means simply the position as a function of time, or displacement as a function of time, velocity as a function of time, acceleration as a function of time, etc. That is called the response of the system. Whereas the excitation function is the input to the system, and the response is the output of the system in terms of displacement as a function of time. So in the design of machine elements or machine tools, you are interested in finding out the response of the machine system to a shock input. So to compare different systems. So different systems will have different natural frequencies. So they find out what is the natural frequency of the system, and for a given natural frequency of the system, they plot the shock response of the system, and they find out what is the peak response. Peak response is the maximum displacement of vibration for a given shock. So the maximum displacement will be different for different natural frequencies. It will also be different for different pulse width. So they will so for each natural frequency and for a given shock magnitude and shock width, the peak response, that means the maximum displacement, is noted, and this is calculated for different values of natural frequency, and that is plotted. That is called shock response spectrum.